In this lecture, we're going to talk about shorelines. And we're going to start by talking about the waves that you see when you visit the beach. So when we're describing these waves, there are certain measurements we can take to describe how big or small the wave is. And in order to do that, we need to understand some terms like the crest and the trough. And then we can talk about what wave height and wave length and wave period means. And then we'll also talk about the motion of water particles associated with these waves. So let's start out with the basics here. The wave crest is the top of the wave, and the wave trough is the lowest area between two crests. So we have the low area, the wave trough, the high area, the wave crest. And if we measured the height, the distance between the bottom of the trough and the top of the crest, that would be the wave height. If we measure the distance between any two subsequent wave crests, that would be the wave length. So this would also be a length, maybe 60 feet or something like that, but it would be a distance that we can measure with a yardstick or a tape measure. One of the things that we can't measure with a tape measure would be the wave period. And one way to think about that is if we could hover a drone right above the word crest here and start a timer when the crest of this wave passes and wait until the next wave crest passes, that would be the period. That would be measured as an amount of time in seconds between when one crest passes by a point and the crest behind it passes by the same point. There are two different types of waves we can see in the ocean. One is called a wave of oscillation, and these would be the waves out far in the ocean if you visit the beach. These would be the ones that are not breaking, that are not causing the surf to occur, but ones further out than that. If you watch one of those waves as it comes in, it will look like the wave is moving towards you and the wave energy is moving forward, but the water associated with that wave is staying at approximately the same place. And what it's doing is it's following an elliptical path as it moves through the water. And we'll take a look at that in a minute. The other type of wave is a wave of translation. That's when the wave motion starts to feel the bottom of the ocean and sort of trips over itself so that the top of the wave is moving faster than the bottom of the wave, and the entire thing breaks right at the shore, which forms the surf zone. So this would be a wave of oscillation. The wave is coming through, so we can see this crest of the wave is moving from left to right across this image here. But if we look at a point of water, or in this example here, this toy boat here, we would see that the toy boat is going to go up that wave as it moves in, and then it's going to go down the other side of the wave. But in the end, it's going to be back at about the same location where it begins. So the drops of water or this toy boat don't really get anywhere as these waves of oscillation come through. They just move in this elliptical or circular manner, but always end up getting it back to about the same spot where they started. This, on the other hand, would be a wave of translation. So here, the water particles, as we can clearly see, are definitely moving. They're being pushed forward. If there was a surfer there, that surfer would be pushed forward as well, and everything would be moving towards the shoreline. Once again, the reason this happens is because where there are waves of oscillation, as out further into the ocean, the waves are moving in this elliptical or almost semicircular pattern. And over time, they're just kind of always ending up at about the same place. But as the energy of the wave moves towards the shoreline, at some point, these little ellipses, they start to feel the bottom of the shore, the sand at the bottom of the shore, and they get slowed down. So the water at the bottom gets slowed down a little, the water at the top continues to go faster, and that's what causes this whole waveform to move from a wave of oscillation to a wave of translation where it breaks. And where it breaks is sometimes called the surf zone, or where the breakers are. This would be right at the shoreline. This is where all the fun happens, where you're able to get pushed around by the waves, and why a lot of people enjoy the beach.